Section 2.5b. Much like what we did in the first half of chapter 2, we are now going to be given zeros of functions and be asked to write the equation or the function that produces such zeros. In the first half of the chapter, we dealt with only real zeros. Now we're going to add in imaginary zeros. The important thing to remember is that imaginary zeros must come in conjugate pairs. So in this first example, we have solutions at -1, -1, which means -1 has a multiplicity of 2, at 3i, but we know if 3i is a solution, then -3i also has to be a solution. Remember, it is impossible to have an odd number of complex solutions. They must always come in conjugate pairs. So now when we go to write our function here, we have f of x equals x plus 1 times x plus 1 times x minus 3i times x plus 3i. When we go to start multiplying these together, multiply real factors together, multiply always our complex factors together. All your I stuff should drop out once you multiply those. So with our real factors here, x plus 1, we need to FOIL this out. We get x squared plus 2x plus 1. With our complex solutions, remember it's always first thing squared minus the second thing squared when we have conjugate pairs. So this is going to be x squared minus 9i squared. Simplify that. X squared plus 2x plus 1. Negative 9i squared, remember, becomes x squared plus 9. Finally, finish multiplying these last two factors together. I need to take x squared here, distribute it through to x squared and 9. We get x to the 4th plus 9x squared. Take 2x, distribute it through to x squared and 9. We get 2x cubed plus 18x. And take 1, distribute it through, we have x squared plus 9. Finally, collect like terms. We end up with x to the 4th plus 2x cubed plus 10x squared plus 18x plus 9. There's our function that has the given zeros. Notice we ended up with a degree 4 function. We had a total of 4 solutions at the beginning, so we know our answer at least makes sense. Always make sure your degree matches up with the number of zeros you started with, or you know right away that you've done something wrong. Letter B. Once again, we know that if 1 minus I is a solution, that 1 plus I has to be a solution. So now we have 3 total solutions. We know we should end up with a degree 3 polynomial. Our polynomial is f of x equals x minus 2 times x minus 1 plus I times x minus 1 minus I. I'm going to leave the x minus 2 till the end. Again, multiply your complex factors together first. Need to distribute x through. Slide this over so I have a little bit more room here. Distribute x through, we get x squared minus x minus xi. Distribute -1 through, we get minus x plus 1 plus I. Distribute I through, we get plus xi minus I minus I squared. Simplify that second factor here. Again, all your I stuff should drop out at this point, or you know you have done something wrong. We get x squared. Negative x minus x gives us minus 2x. Negative xi plus xi is gone. I minus I is gone. We have 1 minus I squared. Remember, negative I squared becomes plus 1. So we have 1 plus 1, which is 2. distribute x through to everything, we get x cubed minus 2x squared plus 2x. Distribute negative 2 through to everything, minus 2x squared plus 4x minus 4. We end up with f of x equals x cubed. Negative 2x squared minus 2x squared is negative 4x squared. 2x plus 4x is 6x. We have a minus 4 at the end. We end up with a degree 3 polynomial. We had 3 total solutions. So that is the degree we should have had. So the biggest thing to remember, if there's only one imaginary solution listed, remember its conjugate also has to be a solution. Rewrite them as factors, multiply everything out, simplify, and that gets you to your original function. Okay, find all the zeros of this function, given that 1 plus 3i is a 0. Once again, we know if 1 plus 3i is a 0, that 1 minus 3i is also a 0. So if I just look at those two factors, I know that those two factors, if I rewrite them, are x minus 1 minus 3i and x minus 1 plus 3i. When I multiply that out, now I'm going to get a quadratic, which is going to represent the factors for 2 of the solutions. We know there is a total of 4 solutions since this is a degree 4 polynomial. And then I can divide that factor into our degree 4 polynomial to find our second quadratic factor, which we then can use to find the last 2 solutions. So let's multiply these 2 factors together. Distribute x through. We get x squared minus x plus 3xi. Distribute negative 1 through, minus x plus 1 minus 3i. Distribute negative 3i through, minus 3 xi plus 3i minus 9i squared. Simplify x squared minus 2x. 3xi minus 3xi gone. 1 plus 9, because negative 9i squared becomes positive 9. 1 plus 9 is 10. And negative 3i plus 3i is gone. So this is a factor then of this original polynomial up here. So now to find the remaining factor, I can use long division. Divide x squared minus 2x plus 10 into that degree 4 polynomial. So we have x squared minus 2x plus 10. And we're dividing that into x to the 4th minus 3x cubed plus 6x squared plus 2x minus 60. Go through your long division. What times x squared equals x to the 4th? X squared, multiply that through to everything here. X squared times x squared times negative 2x, x squared times 10, subtract all that off. 4th degree terms are gone. Negative 3 plus 2 gives us negative x cubed. 6 minus 10 gives us negative 4x squared. Continue the long division. What times x squared equals negative x cubed? That's negative x. Multiply it again by everything. So we get negative x cubed plus 2x squared minus 10x. And we're going to subtract all that off. Cubes are gone. Negative 4 minus 2 is negative 6x squared. 2x plus 10x is 12x. What times x squared equals negative 6x squared? It's negative 6. Multiply. Subtract all that off. Squared terms cancel. X terms cancel. Negative 60 plus 60 is 0. And you should get a remainder of 0 because you knew that this factor that you were dividing by right here produces two of the solutions. If you don't get a remainder of 0 at this point, again, that's kind of a self-check that you know you have done something wrong. So think about all the things that we have done up until now, and you can piece some of those things together to kind of self-check as you are going through these steps. In this first step, when you use these imaginary factors here and here, and you multiplied everything out, if all your I stuff doesn't drop out, you know you've done something wrong. When you go to take this polynomial then and divide it into the original, if you don't get a remainder of 0, you know you have done something wrong. So don't continue at that point. Go back and see if you can find where your mistakes are. So now x squared minus x minus 6 is our final factor, quadratic factor of this polynomial. Factor or use the quadratic formula. In this case, it is factorable. X minus 3, x plus 2. We get 3 and negative 2 as our two real solutions. And then we also knew that 1 plus or minus 3i were two solutions. So there's our 4 total solutions for our degree 4 polynomial.